right. Welcome to United Astronomy Clubs of New Jersey. We are once again here in Jenny Jump State Forest in Hope, New Jersey. I want to welcome everyone who is not only joining us here in person, but also joining us online, because that is right, we do live stream these presentations on both YouTube and Twitch. So if you're ever looking for something to do on a Saturday night at 8 p.m., do feel free to check us out on those. Say hi in chat. Since I do think I saw a couple people just pulling in, I want to give them a couple minutes to actually come down, find a seat, and settle down. In the meantime, I do want to encourage everyone here to check out our website, uacnj.org. Not only will you find a list of all our upcoming talks, such as the one we're doing tonight, but you'll also find links to all of our member clubs, because we are actually an organization made up of other astronomy clubs. And one of the easiest things to do to get into astronomy is to join your local club, since they're going to have so many things available. Many of them have events for stargazing that are going to be close to home for you, so ease of access, as well as they're going to have those tips and tricks for stargazing in your local area that we might not have out here. For example, we do have a number of clubs who are based in New York City, and their tips and tricks and secret hidey holes for the best views of the sky are going to be much more useful to you than any tips or tricks that I know for out here in Warren County, New Jersey, since light pollution is a thing. In addition, you can check us out on our social media, our Facebook, our Instagram. We have a Discord server. If you ever have any questions or problems, or just want to share your cool images of what's going on in the night sky, that's a place to do it. It's also the place to keep up on what we're doing, any special events we may be doing. Like last on-site presentation of the season, since it is so close to Halloween, we always encourage people to dress up and join us in their Halloween costume for the last spooky presentation here until next April. All right, so it looks like most of us have joined in over here. So we're going to have the safety briefing. It is inescapable. I'll probably go through it again because people always manage to sneak in the middle of the presentation. If you need to use the restroom, it is the porta potty in back. It is illuminated by red for ease of finding in the dark. We also have a little museum and gift shop area with things like meteorites on display and some free stuff, as well as anything you buy from the gift shop goes to helping us pay our bills and keep offering these free public programs, since we are a nonprofit organization. And honestly, we are super grateful for all of the support you guys have given us over the years, because it does help keep us going. In addition, you may have noticed the sheds out there. The roofs do roll off, and when we're not under miles of cloud cover, we generally have them open, and you're able to view through the sky. So hopefully at some point during the presentation, the clouds will run away, and we'll be able to show you stuff in the night sky. We also have a couple of our volunteers have brought their own personal setup, and they would be more than willing to answer any questions you have about those and show you what they have going on there. I think Earl had one of the observatories open, so you will be able to at least see the scope inside an observatory, if not look through it. When we go to leave, we are using our headlights, because all of us do not want to get run over. We have a 0 people run over counter for a couple years now, so let's keep it that way. And no one needs the medical bills in this day and age. That being said, since it is a state park and it is getting quite dark, We are going to keep any flashlights, or if we have our cell phones, try and keep that light either turned down or pointed towards the earth so we don't accidentally blind people just walking around. With that, you're not here to listen to me blabber on. You're actually here for a presentation from Walt. Helps if I'm on the right person. Walt Windish has been interested in astronomy since he saw the Pleiades as a Boy Scout. He bought his first telescope many years ago, just in time to see Halley's Comet. Walt is a member of the North Jersey Astronomical Group and Rockland Astronomy Club. He's been volunteering here at Jenny Jump for over 20 years, and with that, he's here to tell us about smart telescopes.
Thanks, Kim. Well, good evening. How many are camping out tonight? All right. You got a great night for it, even if it's not a great night for astronomy. Although if you like to stay up late, I hear it's clearing up around 3 or 4 o'clock in the morning, just in time for sunrise. You know, my talk tonight is different than my usual talks. Usually what I do is I use a lot of Hubble Space Telescope, James Webb pictures, professional pictures, and talk about a specific subject that I'm interested in at the time. But tonight I'm going to talk about smart telescopes. I hadn't bought a telescope probably for 20 years. I have a couple nice telescopes that I use for observational astronomy and also astrophotography. I started out with film, went to DSLRs. Never bought a dedicated astro camera though. But lately, they've come up with this new type of telescope called a smart telescope. And I started to get real interested in it. And over the last 8 months, I bought a small one and then a larger one. And so what I want to do today is just talk about my experience with these new smart telescopes. I think that they'll really bring astronomy to a lot of people. They're very simple. And being a slacker at heart, I really like the fact that you can set these things up in 5 or 10 minutes and be observing in no time. So what I did, almost all the pictures are mine unless I tell you otherwise. And I didn't do any post-processing. You know, like in any hobby, you can get as crazy as you want in the details and in the amount of work you do. What I wanted to do was use the photos that I took right out of the telescope, exactly what the telescope gave me, without punching up the colors, putting it in Photoshop, or putting it in one of the other programs like Serial or PixInsight. I wanted to show you what you could expect to get if you were to get a smart telescope and start taking pictures. And I'm also not here to compare specs and present you with a buyer guide. That's pretty boring. Anyone interested in that stuff can watch YouTube videos till you're blue in the face. So I will not be, won't be doing that either. Although I will have one spec sheet just to show you some stuff. So a major reason, as I've already said, this smart telescopes caught my attention is that I really am a slacker at heart. I don't like spending hours setting stuff up. I'm not into a lot of post-processing or any of that stuff. And here you'll see some real astrophotography setups, and you can catch these. These were taken right here at Jenny Jump. These are some of our member scopes, and they produce absolutely stunning images. And what we call data collection, the way these scopes work and smart scopes work, is that you take a bunch of pictures of the same thing. We call them frames, and in the case of these could be a minute to a couple of minutes long, and then you stack them up, and the frames on top of each other electronically actually add to the light, and you can get amazing results from that. And some of the pictures that have been taken with these scopes, you have 10, 20, 30 hours of data that's collected and then stacked to make one photo. That's on the far end. So that's a lot. What I'm doing on the smart telescope, I'm taking 10 or 15-second exposures, and I'm stacking up about average 20 to 50 minutes worth of data. So there's quite a difference. And again, I'm not saying that that the stuff I'm taking is as good as the stuff they produce, but you can still get some amazing stuff. One big difference between these scopes and mine, besides the multiple cost, is that these mounts here are called equatorial mounts. So this is pointed the same direction as the axis of the Earth. And so it turns the entire telescope to compensate for the rotation of the Earth. And that's a big deal. That's why you can take longer exposures with these of 1, 2, 10 minutes, because you're following the Earth. All these smart scopes, they use an alt-azimuth mount. And they follow the object, but what happens is you get something called field rotation, because they're not following the rotation of the Earth, the stars around them rotate a little bit, and it gets a little funky after a while. But if you crop in the middle, you're fine. And since I bought my scopes, there's now software to do equatorial mounts. I can, for a certain amount of money, anywhere from 50 for the small telescope to a couple hundred for the larger scope, you can put it on an equatorial mount. But that defeats the purpose of what I was looking for. I was looking for something simple, take the grandkids out, take a look at the sky, and do some EAA. That's called electronic assisted astronomy. So not only do you take pictures, but I can put an iPad down next to my telescope, because the smart telescopes don't have eyepieces. And people can gather around and look on my screen and see exactly what I'm taking pictures of. There's some of the guys that work here. This is some astrophotographers here at Jenny Jump. They're gathering data. And as I said, they could gather 10, 20, 30 hours worth of data on an object that they're interested in imaging. If you want to see the stuff that they put out, in the museum, we have some images. You could buy last year's calendar cheap, and that's full of images, or you could buy this year's calendar. They're all done by club members using astrophotography rigs. So back last October, I heard about a super portable smart telescope for $349. And it's called the C-Star S30 from ZWO. And that's a company that makes some really decent astrophotography cameras. It's now $400, but that's still pretty cheap. But it's under 4 pounds, and that's the size of it right there. That's the whole thing. Little tripod, telescope. What I wanted was something I can stick in my travel bag and bring on an airplane and travel somewhere with it. So I wanted the smallest thing. It's not the best resolution, but it was pretty cool. Here's a photo of it with its arm extended. It's only a 30 millimeter opening right here. That's the opening for the telescope. But it combines a telescope with a GPS, with a camera, and a hard drive and a Wi-Fi hub, all for $400. And it does it pretty good. You'll find a lot better, but for $400, I think it's a real bargain for what it does. And it's going to get a lot of people interested. I mean, you get a couple of kids together working on a science project, they could do amazing stuff with that. And as I said, most smart telescopes don't have an eyepiece. And the one that does, it really isn't an eyepiece as you think of a telescope. It's really one of those electronic viewfinders. So you're really looking at a little TV screen in the eyepiece. You're not really looking directly at the object. And so there's really no substitute for coming up here and looking through a real telescope and seeing like Saturn or Jupiter for the first time with your own eyes, not on a screen. There'll never be a substitute for that. That's amazing. But your eye acts as a shutter speed of about 1/30th of a second. So no matter what you look at, except maybe bright Jupiter, you're never going to see colors. You're going to see fuzzy white objects as nebula. And these, in 1/22nd exposure with this camera, you start to see color. So this is first light on my camera. I ordered in October. It came in January. I walked out my front steps, put it on my front walk in Wayne, New Jersey, not a dark sky site. I mean, it's pretty light polluted. And And the way these scopes work is you download an app on the telephone or on an iPad, and you control it from there. And as it takes images, 20-second images, it stacks them one on top of the other, and you see the result right on your screen. And there's also some work in the background where it's stretching it. It's making the colors as vibrant as it can from what it has to work with. It's not making up colors, but if you were to look at just that exposure, you wouldn't see any color until you electronically took those color channels and stretched them so that you could see something. But this is what I saw in my phone after 2 minutes and 20 seconds. It's the Orion Nebula. Granted, an easy target, a bright target, one of the easiest ones you could fit, but you can see it's looking pretty good. That was only 7 seconds. I enlarged it just so I could show you what noise is. This is electronic noise. See all that stuff? It looks, all those different colors, those are just, that's what we call noise. And you can denoise that using, right here it has, the telescope has an AI denoise function, which I've not used on these photos. Again, I just want to show you with no extra effort what you can get out of these. So that's Orion. That's the final output of the imaging. No, it's not. That's another intermediate step, 26 minutes. And you can see the noise level has gone down. The more exposures you take, the more time you take, the better your signal to noise ratio is. So the more detail you see in the image and the less background noise you're going to see. And so you want to take as long an exposure or a long set of exposures as you can in order to get a good picture. And then you can come in with the post-processing and use an AI denoising and all that good stuff. Again, I think that image is great for a $400 telescope. There's another close-up just so you can see there's still some noise in there. That's just a crop of the picture. And then finally, there's a cropped Orion, 105 stacked images, 35 minutes. So that's 35 minutes total exposure on that. Again, less noise, richer colors. You see more of the tenuous filament arms coming out. Pretty good. So between the time I ordered my S30 and the time it actually arrived, I got a call from my son telling me that he wants to take me and my wife to New Zealand. So he didn't have to ask me twice. He wanted to go in March. It was just something that came up. He didn't do it around astronomy. So we were like 10 days out from a full moon. It wasn't perfect. But with a 4-pound scope, I threw it. That's exactly what I bought it for. I threw it in my pack, and we went out there. So there's he took us to a place called Wanaka. He rented a house there, and that's just a view of the skies that were there. Astronomers rate skies by the amount of light pollution they have. So a Bortle 1 or a Bortle 2 sky would be prime sky. New York would be around a Bortle 9. Wayne is probably 6. So these were like really pristine skies. Probably a Bortle 2, maybe even a Bortle 1. I'm not sure about that. I didn't look it up. So with this C-Star 30, this is the first image I took. It's a globular cluster known as the Omega Centauri, or Caldwell 80. It's located about 17,000 light years from us. And it's the largest known globular cluster of the 150 or so known globular clusters that are circling around the galactic bulge of our galaxy. Down there in that sky, and because this is the largest one, it was a naked eye object. I could see this with my naked eye, and you just can't do that. We've got some great clusters. A Hercules cluster here is, you can see faintly with binoculars, but nothing naked eye like this. The diameter of this is about 450 light years, which means that it takes light 450 years just to travel from one end of the cluster to the other. And just to back up, when I say it's 17,000 light years away from us, you can think of a telescope as a time machine. Because when I say it's 17,000 light years from us, it means it took that light 17,000 years to get to us. So we're not seeing the cluster as it appears today. We're seeing it as it appeared 17,000 years ago. That's why astronomers want to look further and further into the universe, because if you look back, and they have already, 12, 13 billion light years at a galaxy, you're looking at a galaxy that was formed a couple 100 million years after the beginning of the universe. And so you can study galaxy formations by looking further and further back in time, by looking at farther and farther galaxies. So this was taken March 5th around 9:30, 55 20-second exposures for just over 18 minutes. Here's another of Omega Centauri I took on March 15th. 1 day past full moon. So there was a bright moon in the sky when I took this picture. And I only took 31 frames for a total of 10 minutes. Pretty good. With a 30 millimeter opening on my telescope. This is Caldwell 92. It's an emission nebula known as the Carina Nebula. And the James Webb Space Telescope has taken some amazing pictures, if you ever want to look that up. It's about 7,500 light years away. And the interesting thing is at the heart of this is a star known as, or a system known as Eta Carina. It's got at least 2 stars. And the largest star is Eta Carina A. And it's about 100 times the mass of our sun. And it's about 5 million times as luminous as our sun. So, and that's in our galaxy. So although our galaxy has hundreds of billions of stars, there's only tens of stars that are as bright and massive as Eta Carina. Here's a beauty. This was an amazing little beauty. It's called the Jewel Box. The Omega globular cluster I showed you had a bunch of ancient stars very tightly packed together. That's a globular cluster. This is an open cluster. These are some of the youngest stars in our galaxy. And they're not as tightly packed, nor are there as many of them there. The Jewel Box is an open star cluster 6,500 light years away in the constellation Crux, which is the Southern Cross. You can't see that from here. Like everything I've shown you so far, you can't see the stuff from this hemisphere, the northern hemisphere. This was taken on March 5th using 97 stacked frames for a total of 32 minutes. Look at that amazing star field. That's just a crop. It's the same photo. I just cut it so you could see it a little closer. And when you're looking at the quality, you know, one of the things I could do if I spent time calibrating is getting some of the colors of the stars right. These stars aren't quite right. And also, you usually want to cut at least the edges away. But you always look for how round are the stars? Is there any kind of linear to them when you're looking at a photo? I think it tracks pretty good. It's not the greatest resolution, but it tracks the stars fairly well. This is 2 images of the same object. About 1,600 light years from us is the Large Magellanic Cloud. It's a dwarf galaxy that is very close to us. Down in the skies I was at, I could see both of those clouds, the large and the small, naked eye, as they almost look like clouds. They really stood out. And this is called the Tarantula Nebula. So to photograph a nebula in another galaxy is next to impossible unless the galaxies are really, really close, like the cloud. It's known as NGC 2070. It's a beautiful diffuse nebula. It's in the constellation Dorado. And it's so bright, the reason why it's so bright is there's a massive cavity at the center of the nebula, blasted out by young hot stars. Stars are being born out of that gas that you're seeing as nebulosity, and ones that have been born are just blasting the gas away. The image on the left is only 100 seconds, so that's five exposures. When I looked at it on my phone, I realized that I wanted to recompose the image so that it would be up more. So I recomposed, and then I took 37 frames on the right for a total of 12 minutes. You know, it helps when you have really dark skies as far as the exposure time. 12 minutes, probably in Wayne, you'd have, if you could even see that, you'd want to go a lot longer. This is another beauty from down under, although this we can see close to the horizon usually, but we can see it from up around here. It's called the Rosette Nebula, and there's also a open cluster in the middle, in the donut hole, known as the satellite cluster. So it's really a double object. The Rosette Nebula is known as Caldwell 49, and it's a hydrogen 3 area. So if you put a filter on it, you'd get a little more red. This smart telescope has a built-in, they call it the LP filter. It's really a dual band filter which lets hydrogen and oxygen through, and so you do get more red, and it automatically switched to that filter as I was taking it. This is about 5,200 light years from us, 65 light years across. It was taken on March 7th, and this was 70 minutes. This was a long exposure. And again, I can get a lot more red out of that if I did post-processing. But this is what it will deposit right into your photos album. When you're done taking a picture and you tell it stop recording, it does do a little processing itself, and then it sticks it right into your photo album. And that's what you see. The last image from New Zealand I want to show you is this. This one, it doesn't look that impressive, but it's really an amazing object that I'd never thought that I'd be taking an image of. It's called Omega Centaurus A. It's a galaxy in the constellation Centaurus, and we believe that it was formed by 2 other galaxies colliding together and forming this. It's known as Caldwell 77. It's about 11 million light years. You'll notice when I talk about nebula, it's usually hundreds or usually thousands of light years away. When I talk about galaxies, it's millions or billions of light years away. So this is 11 million light years away, and it's classified as an elliptical galaxy. This is the exact same image, just cropped, just so you can see that dust lane. That dust lane is just, I can't believe I caught that on that little telescope. It's just amazing. This is one of the closest active galaxies to us. And when you say active galaxy, it means that there's a supermassive black hole that's active in the center of this galaxy, just gobbling up any kind of cosmic matter or cosmic debris that comes close to it. And then it emits radio waves, X-ray, and gamma ray bursts. And we can hear those over here. So pretty wild stuff. A lot of times I tell my grandchildren, you know, you can read science fiction, you can watch it on TV, and that's a lot of fun. But a lot of this stuff is stranger than fiction. And it's so much more exciting because it's real. And so when you're looking at this stuff, when you're reading about this stuff, you're learning hard science. You're not just exploring someone's imagination, which is a lot of fun to do. I'm not knocking that. I'm just saying, don't forget about the hard science, because most of the science fiction writers are using hard science to write their fiction as well. This galaxy is about 60,000 light years wide. Compare that to our Milky Way, which is 105,000 light years wide. So it's about 60% the size of our galaxy. So I got home from New Zealand all charged up about the ease of a smart scope and how it really fit my slacker mentality. And but I wanted better resolution. You know, that's the problem with a hobby. It's a disease. Um, so I did what any spoiled astronaut would do. I went out and I bought a bigger smart telescope on the opposite end of the spectrum. It's called the Celestron Origin, and that's it on the left, and the S30 is on the right. Quite a difference. And one thing I learned when I was using telephoto lenses in with photography for birds: be careful where you point the thing. I was photographing a what was I photographing? I think it was the East Vale Nebula, and I had my scope pointed right down here because that's where it was. It was low in the sky. And after I took pictures, I took a quick picture of the scope and pointing there just for my records, and I just realized I'm lucky someone didn't call the police with a perv report, because you know, you look out your window and you see some idiot with a cannon like that pointed at your window. No good could come of it. But I swear I was between the two houses, but they would never know that. So that's the Celestron Origin. We're going to take a look at some of those as well. And this is the only data table I'm going to show you. I promise. But the most important spec on a telescope, you know, you see a lot of department store telescopes and they'll say 1,000 power and all that. The most important spec is how big the opening is. How much light can that thing catch? If you're not catching enough light, the magnification means nothing. Those telescopes you buy in a department store with 1,000 magnification, they're totally useless. The tripod isn't steady enough for it, and the aperture isn't big enough to get any kind of useful resolution. So stay away from that. Just get a good sturdy mount and a good opening. So this aperture here, the S30 has a 30 millimeter aperture compared to the Origin's 152 millimeter aperture, which is way on the high side of these smart scopes. So that means that the Origin gathers 25.6 times more light than the S30. It also results in greater detail. And if you use eyepieces, as I said, more magnification. But neither of these scopes have eyepieces. You just can't use them. You're using a screen to look at what you're taking pictures of. The focal ratio is the ratio of the focal length to its aperture. It indicates how quickly it can gather light relative to its focal length. f2.2 is unbelievably fast. I've never owned a telescope faster than an f6. So an f2.2 is just a super fast telescope. Camera lenses, there are a lot of camera lenses that go under f2. But a 1 hour exposure at f2 will take 6.25 hours at f5, just to give you an idea of the difference that f2.2 makes. And that's not even considering, that's all things equal. The apertures aren't equal either. So, I mean, you compound that. This new telescope is much faster. You have to be careful not to overload the sensor with too much light when you're shooting some of the brighter objects. So you'll notice that the Celestron Origin is almost 10 times heavier than the CSAR 30, 41 pounds compared to 4 pounds, and it's 10 times more expensive. But if you look at dollar per pound, the Celestron's a bargain at $96 a pound. But that's a totally useless specification. Don't listen to me. I'm ridiculous.
I think I would care if we were like talking about steak.
Exactly. It would make a difference if we're talking about steak. Thank you. But not with telescopes. It's got a heavy tripod. But still, this telescope, I put the tripod down, I put this piece on top, I slide this into the mount, and I take one wire and connect it from here to here. I'm ready to observe. Literally 5 to 10 minutes, I'm set up and I'm ready to observe, compared to 1, 2, 3. I mean, when you have an equatorial mount, you've got to polar align that thing. and you've got to hook up all those wires. So if I were to give you a summary, I would say the CSAR S30 at $400 might not have the most resolution, might not be the best scope, but it's the bargain. For what you get for $400, that's an amazing bargain. The Celestron, you're paying a little extra for convenience. You could go into the market and you could build a telescope with this capability and even make it a little smart scopish, because there are now cameras that have the controller combined. So you could probably imitate that for around $3,000, $3,500, but you won't have the same convenience. And you'll still have a lot more wires. And just, for me, if I'm going to use it, I want to get out there. So C-Star bargain, Celestron, you're paying a little more for the convenience, but you're getting an amazingly good and amazingly fast scope. I'm very impressed with it so far. So I had to take my scope somewhere. I took it up to the Adirondacks to a place called Camp of the Woods in Speculator, New York. And here are the first images I took with it. Again, no post-processing. Here's the Trifid Nebula. And that's not cropped, that's a full frame picture. Also known as M20 in the constellation Sagittarius, which we'd have a chance of looking at if we could. It's about 5,200 light years away. And I love the combination of the red emission nebula, meaning that a star is exciting the hydrogen molecules in the red part and making it glow red. And then the blue is a reflection nebula, which means that the molecules aren't being excited, they're just reflecting lights that's being shown. So you got an emission nebula, a reflection nebula, and you got those dust clouds that are cutting interesting shapes into it. It's just one of my favorites. And that's what I did. When I went up with the scope for the first time, I went out and I looked for some of my favorite objects that I was familiar with and that I wanted to take pictures with. I think the AI, I know, even though I don't do post-processing, I know Celestron's doing some processing there, not only stretching. I think the AI might be a little heavy-handed on that black sky. I don't need it as black as that. And again, the star color, I need to do a calibration to really be happy with that picture. But otherwise, it's just an amazing photograph for the amount of effort. There's this guy on YouTube. I think he calls himself the Lazy Geek, and he talks about getting 90% of the way with 10% of the effort. That's a man after my own heart. So that's what this is right here. This is 90% of the way with 10% of the effort. Here's the same photo cropped, just so you can get a little closer look of it. So it's important for astrophotographers to understand what type of objects they're shooting. The CSAR S30 did switch filters once in a while automatically, and I could have backed that off, but I let it pick what filters to use. And by the way, the CSAR also has a magnetic solar filter, so you can take pictures of the sun and sunspots very nicely. I didn't do that. I usually use a camera when I do that, but you can do that and the moon as a bonus. You can't do that with the Celestron. Well, you could put a solar filter on it, but in the $400 package you get the solar filter. So that's another plus. So astrophotographers need to know what kind of nebula they're dealing with, because there's a dual band filter that lets just hydrogen and oxygen through, and it's great if you're in light polluted skies like Wayne, and you would use that on something that's red, something that's an emission nebula, but you wouldn't use it on a reflection nebula or a galaxy or anything like that. So you got to understand, if you're going to use filters, what you're looking at, because filters do cut down light. There's a price to pay for using a filter. You cut down light pollution, but you also need a longer exposure. There's a gorgeous galaxy. Let me just see. I'm just trying to see where I am here. Yeah, there's about 50 minutes of data here. That's the Pinwheel Galaxy. and I was very pleased with the way that came out. A little processing would put some more hot spots on those ridges and bring the definition out a little bit. But these are 10-second frames, 50 minutes worth. It's called M101, and it's in Ursa Major. Ursa Major is right where the Big Dipper lives. That's the constellation. It's about 21 million light years from us, and we think this is what, or close to what, the Milky Way galaxy looks like from afar, with its spiral arms and the like. Although with at least 1 trillion stars, it's nearly twice the diameter of our Milky Way galaxy, so it's quite large. But look at the detail. You can see the tendrils of that galaxy reaching way out, even on this screen, which is, you know, pretty shoddy as far as what you see. Here's a crop image of it, a little closer. Just a pretty, and those stars are nice. There's not much coma elongation on them. They're a little thick, but on the bottom you see one that's a little elongated. But I had a lot of fun breaking in the Celestron, going to my old favorites. This is one I love. It's called the Eastern Veil Nebula, NGC 6992, and yeah, those colors are just what Celestron gave me. Of course, Celestron stretched them. You know, with both telescopes, you could go into their hard drives and you can get a master stacked, and then you can get each individual frame if you tell the scope to save those frames. And if I took the master stacked of the Veil Nebula, I would barely be able to see the nebula at all until I put it in software that stretched it. So the Celestron, I say these are coming out of the scope without any post-processing. Understand that these smart telescopes are doing some processing. They're definitely stretching it so they bring out the colors, and I think it does a great job. This is just an amazing job of bringing out the colors here. This is the entire Veil Nebula. We looked at the eastern edge. So what we looked at was right here. Matter of fact, the Celestron cut it off around here. So that's what we were looking at. But the entire object, the Veil Nebula, is this. And it's about 6 moons wide. So it's one telescope is not going to be able to capture every object that you want. Some are huge like this. This is a supernova remnant. This is what's left behind from a star going supernova and just blowing out its elements. Hydrogen is the red, oxygen, and I can't think of the other. But it's just amazing. You really need a DSLR to capture the whole thing in one. This is a professional telescope that is ground based. But I wanted to show you what this remnant of this ancient supernova explosion looked like, and just how little a section I photographed with the Celestron. So when we photograph objects, anything this big, 6 moons across, all the way down to the tiny ring nebula, which is a very tiny dot in the sky. It's a dot with a smoke ring around it. Very tiny, very hard to photograph with the Celestron. So you need different focal lengths to take pictures of different objects, just like a photographer does when he's doing landscape versus portrait versus micro. On the left is the same image you saw from my Celestron. On the right is a C-star image. Very unfair comparisons. The S30 is about 50 minutes of exposure compared to 30 minutes on the Celestron. You see a lot more detail. You see that because the C-star has a wider field than Celestron, it actually fit the entire piece of the Eastern Veil in. You get more red because it automatically switched to its filter. but I shot that one from Wayne, so you really can't blame at all on Celestron. So I didn't give my Sea Star a chance to go out to the Adirondacks and take that shot. So you can see there's a lot of noise which can easily be removed with software. But that's what you would get right out of the Sea Star. The dual band filter accentuates the hydrogen and oxygen, which is the red and the green. It really accentuated the hydrogen. You can see that. This is the Dumbbell Nebula in Vulpecula, and another one of my favorites. It's 1360 light years away. In the center is a white dwarf, which is what's going to happen to our sun. Our sun is not massive enough to go supernova at the end of its life. What happens, it will burn all of its hydrogen, switch over to helium, start to expand, turn into a red giant. At that point, we'll be inside of the sun, and it'll shrink back, and then finally, the outer shell, which is about half of the sun's mass, will form a shell like that, and in the middle will be a white dwarf, a remnant star that's no longer undergoing nuclear fusion. It's cooling down and take about 1 trillion years to cool down, and half the mass of the sun will be packed into a space the size of Earth. So if you were to take a teaspoon of that mass, you wouldn't be able to lift it. It'd be about a ton or two. So very, very dense white dwarf. And there's a lot of, they call these planetary nebulas. They have nothing to do with planets. But back in the 1700s, when they were looking in the sky, they thought these things looked a little like planets. And they knew they were nebulous, so they called them planetary nebula. They didn't know what they were. So that's in the Dumbbell. Here's a cropped image. And you can see right in the middle, a white dwarf. You can see pretty intricate structure there. That's a pretty small image. Well, in the constellation Serpens, you'll find our next image, which is called the Eagle Nebula. This is made popular by both the Hubble and James Webb have taken a lot of pictures of these. This is this was taken with the Celestron in Speculator. It's about 7,000 light years from us. And the most famous part, this whole thing is famous, but right here are the pillars of creation. There's 3 pillars, and you can see them. You see them better on my computer screen, but you can see 1, 2, 3. The longest pillar is about 4 light years long, so it's pretty long. And again, just an amazing amazing photo for the effort that I put into it. I cropped the image a little bit so we can see the pillars of creation better, right in the heart of the Eagle Nebula. This is a hotbed of star-forming activity. This was 217 10-second images, so that's 36 minutes of data collection to come up with this. Here's a cropped image from the Sea Star. This again was in light polluted skies. You can see the gradient. It's very light down there, but you can still see the pillars of creation there. This is 516 10-second exposures, so this is 86 minutes worth of data on the Sea Star. So 36 minutes for Celestron, 86 for Sea Star. And I ran into field rotation problems. If we have time, or a question later, I can show you. But I did see where it's getting some field rotation that I wouldn't have if I had used a different mount. But the field rotation solved with cropping and a free program, Graxpert, will take care of the gradients, and then you can use something. There's a great free software called Cyril, which will really help you spike up these pictures. And if you got a lot of money, there's PixInsight, which a lot of people use, but I'm too cheap. I think that's like $500. This is a professional ground-based image, just so you could see what the pros who do a lot of post-processing, they spent a lot of time post-processing this. But again, if you look at the pillars, they're pretty close to the other image. Matter of fact, I think here's a side by side. Both I can enlarge that a little, but both images are pretty close as far as the pillars. But this really, you can see more nebulosity. Stars, I wouldn't say the stars are a whole lot tighter, and I'm sure that's $10,000, $20,000 plus for that professional observatory. And if you have a few $1 billion laying around, you could buy yourself a space telescope and really get a good shot of the pillars. That's the Hubble invisible light, and that's the James Webb telescope in infrared, near infrared. So the near infrared, that's a whole nother game. But you can see how it cuts through the dust and lets us get a look at the stars. This is a huge star nursery. If you look here at these 4 stars, you can only see a hint of one of them in the visual light. So that's where I am so far, playing around with smart telescopes. I hope to do something next year on it, but thanks for stopping by and listening to my spiel.
All right. Thank you, Walt, for another great talk. So we are going to do a question and answer session. But before that, because I noticed that a couple people sneaking in, I just want to briefly go over the safety guidelines. If you need to use the restroom, that is the porta potty in the back. It is blue. It is illuminated by red because it is quite dark, and it would be hard to find in the dark otherwise. We're still cloudy, but I do believe we still have a scope open where you could at least see the scope, although you won't be able to see anything through, since visual telescopes do not actually help when there are clouds out. We also have a museum area and gift shop. Feel free to check out our displays of things like meteorites and whatnot. And when we go to leave, we are using our headlights. We prefer not getting run over. We prefer not having to do paperwork because someone gets run over. So let's just avoid that hassle altogether. And at least someone's laughing. Any flashlights or cell phone lights we might be using to wander around, because, again, it is a state park and dark. Do try and keep those lights pointed down. We don't want to accidentally blind someone. With that, how question and answer session is going to work is I'm partially night blind because I've been staring at a screen. So for everyone here, you're going to raise your hand and then wave it about like you just don't care, and keep your hand up until I get you with the microphone. Otherwise, I lose you in the void of darkness. You will be, I'll hand you the handheld mic here, and you can say your question, because chances are if you have that question, someone else might have it or have a great follow-up question, but not be brave enough to say it. Online people have it easy. They just get to type to me. And I am going to start this out with our first online question, which was, they have heard rumors that some of the smart telescopes don't actually use live photos of the object, but rather a library of images for those objects. Is there any truth in those rumors?
I heard that rumor on one scope that they relied too heavily on that. I'm not sure if that's true or not. Certainly these scopes and most of the scopes, that's totally ridiculous. And I can prove it just by looking at the flats, right? I have a record of all of the flats that were taken, and I can restack those myself, and and you can see sometimes a flat is discarded because a satellite went through it, or something ruined the shot. the scope is smart enough to actually say, I'm not going to put this in the pile of stacks. And then you can go back in your stack and you can see that one that they didn't use. So yeah, all the data that's used to produce those pictures I showed you are residing on my telescope. And there's a file for every single image. So yeah, no. But you know, some of the processing, like Cyril, will ask you, what image are you processing as you're post-processing it? And again, I didn't use that on any of these. But it'll ask you what image, and it knows what the star colors are. And so as it does a color correction, it uses data that it knows already in correcting the colors on your image. And you know, there's quite a controversy even in regular photography and astrophotography over what's a proper use for AI in processing photographs. Certainly the least controversial in astrophotography is removing the noise. I showed you all that noise. That's not controversial. But sometimes if you're spending too much time looking at another photo and making your photo look like that, you know, you could take it that far. And I think there are quite a few in the community that say that's going too far with AI. So yeah, that's still a question. I don't go crazy over it. I know that this is not taking a photo from somewhere else and giving it to me as my photo. What I took. And this is a hobby, and I'm not going to get an ulcer over a hobby. Some people people will argue anything on social media, and I'm just not up for that. I do think that too much AI kind of ruins your own feeling of creating something, because you didn't create as much as you may think you have.
All right. I saw a question right here in the front.
Okay, so
If you want to.
very new to this, so thank you again for all the information. But I was curious, at the end you showed two comparison photos. It was the, Hubble and the James. Do you have examples of similar ones using your two pieces of equipment?
Well, I don't have any infrared equipment,
Well,
right?
or an equivalent of comparing your two?
Where was it? There's one. Yeah. Oh yeah, they're both. Those are both mine. Yeah, that's the Celestron taking the Veil Nebula in the dark skies of the Adirondacks, and that's my CSAR 30 taking it in the whitewashed skies of Wayne, New Jersey. So it's not a fair comparison, but it kind of shows. It also shows that this has a wider field of view. It got the whole eastern piece in there.
And so when you took those comparisons, those were on different dates?
Yes, they were.
Okay.
Yes, they were. They're about a month apart.
Thank you.
All right. We have another question up here.
The one on the right was only a week old.
So is the Sea Star one the smaller one or the bigger one?
That's a smaller one, is a Sea Star.
Okay.
All right. So while I'm traveling back to that next person with their hand raised, our next online question is, why did it take so long for you to get your scope in the mail? October to January is a number of months. Was it pre-order?
It was ordered. Sometimes the supply chain just gets hokey. The Sea Star was coming out of China. They were saying we'll probably get it to you by Christmas. They didn't. They got it to me in mid-January. And I think now you can take delivery on it. But I noticed that the Origin, everywhere I see the Origin, it says out of stock, and there's no explanation. So these things are really popular. And the Sea Star at $400 really is an amazing bargain. I'm not surprised that they can keep them in stock. The Sea Star, I ordered it in October. I got it January of this year. Yeah. I think maybe the person who has it the longest may have it for a year.
Yeah, one of our online viewers says back orders for telescopes can be even longer. One of their friends had been waiting for 3 years to get theirs. I skipped that wait. If you go to astronomy trade shows like NEAF, Northeast Astronomy Forum. Hello, there we go. I bought the flow model. I had instant gratification and a discount because for a display model. So we're going to move on to the next question back here.
One thing I'll just add for 1 second is that there's an S50, which is a larger scope and it's got a tighter field of view, so there's a little better resolution. It's about 500. It might have gone up to $550. If you don't need to stick it in a suitcase, it's just a little bigger. They have those in stock, and that's a pretty good scope too. There's a bunch of good ones. If you spend time on YouTube, you will see a whole slew of scopes, and you can get all kinds of comparisons. There's one channel called Astro Koala, and she does an amazing job comparing scopes. I think she's in the Canary Islands, but some really great videos she's had comparing and then going through post-processing, and you could spend days watching those videos.
So
Yes, sir.
this isn't a question referring to the telescopes, but this is a fun question. What is your favorite part about astronomy?
Ooh, good question.
You know, I'm sure it has changed over the years, but right now, and I'd say over the last 10 years, my favorite part is getting a 10-year-old looking through the telescope and seeing Saturn or Jupiter for the first time, and just watching them go, wow, because there's nothing like it. I love sharing it, and that's a big reason why I got this, is because now I can put a tablet on a stand, and people can just stand around and watch the image form, and it's just amazing. I love sharing this stuff.
All right, we got another question back here. Oh, never mind. We're swatting at the mosquitoes. Oh, there we go.
Hey, Walt, thank you for the presentation. And just if you are familiar with, say, sharp cap on the left side and the C star on the right, how locked into settings and things like that are you with the robotic? Are you ever frustrated with not being able to take, say, as long of an exposure you want, or having the ability to take more darks or anything like that?
Well, you know, as far as darks and stuff, the darks that come with both these scopes is great, but you can retake your darks and lights. You can take all that stuff. I guess one of the frustrations I had recently with the Celestron is I have a 2-inch dual band filter, and I put it in. I wasn't going to spend a whole lot of time imaging, and it just couldn't focus because it was so dark, and I was in light polluted skies in Wayne, and the manual, like if I had my old scope, I just turn a knob to focus it. You put it, you know, and just look through the guide scope. And it was just very frustrating. I had to press, you know, a button or put in a number, and then finally I saw this hazy round object, and I said, "Oh, that's an out of focus star!" Finally, and it took me forever to focus on that because of the filter. It never happens without the filter, but that was one of them. And then the other one is after I focused it, the star wasn't close enough in the field of view, and I had to move it, and just the controls to move it. You know, if you have to go outside of the automation, it does give you control, but it's not the same as a regular scope for sure.
All
Yeah.
right, so I do have an online question, and I'm going to clarify for this viewer online. We may not be able to get the answer to this tonight. We did have another viewer in chat try and help you, but this is a question that you need to know some math.
Oh, forget it. I'm a slacker. How many times did I tell you I'm a slacker?
And hey man, I got 500 millimeter focal length lens, and the aperture of it is 80 millimeters. Actually, Paul, you might be able to help. Which they heard these measurements are great. They're just lost on what focus lens they should get for their DIY telescope.
Wait, you got an 80 mil aperture? Isn't that the
500 millimeter focal length
right?
with an aperture of 80 millimeters.
So that sounds like a telescope.
Yeah.
So what's the question? I'm sorry. It said what kind of telescope should I get, but that is a telescope.
I think they're looking for lenses.
Well,
I'm wondering if they're thinking of mirror, like they have a mirror and they need the lens portion to do the light thingy.
I just don't get the question, so I'm sorry.
The only thing that I think would be nice
Hold on.
All right, so some of the basic math, if you know your aperture and you know your of the telescope, and you know the focal length of the you know the aperture, you know the focal length of the telescope, you know the focal length of the eyepiece. Of course, the ratio of focal length of the telescope to the focal length of the eyepiece will give you the magnification, because you always need
Right.
two pieces in order to get the magnification. Once you have the magnification, you can divide by the field of view, and you get the apparent field of view, and you can get the true field of view. And so that's the only math that I'm aware of that person might be trying to get.
And then it's an f6. You can calculate it's an f6. So
Right.
the speed of the optics.
Exactly.
All right, and because
You have a comment on that?
I think she had a question that happened before the online question. I will get to you. To clarify, because some people may be out here also, like I said, one of our other online viewers wanted to help because they do fun telescope things. They would recommend to the viewer on YouTube to use eyepieces of focal lengths in the 15 millimeter to 35 millimeter range for an f6 telescope, because that sounds like what the math is. The best thing is to try eyepieces at like a star party, where you could be like, hey dude, can I see how this works with my stuff? But if you have to buy an eyepiece without trying them first, they would recommend a 20 millimeter or a 30 millimeter Plossl.
That's a good place to start.
Yeah, and additionally, you can get something called 2 times Barlow, which effectively multiplies the number of eyepieces you have by 2.
Woo! Math. It is beyond my know-how, which is why I got a Dobsonian, so I could just plop it
There
down
you
and be
go.
like, hey, sky.
Yep.
But I did have the question over here.
So, which one is the sea star and which one's the other one in that
The
photo?
sea stars on the right, and the celestrons on the left.
The sea star is the picture where he didn't actually give it a chance to succeed.
Hey, I gave it twice as much exposure.
Okay, you shortened the distance for a horse race where you've already tied his 2 legs together.
Okay.
All right.
I won't argue.
Do you guys use math a lot?
No, I don't. You know, there was a time back when my son was younger. We did some math. He built a 6-inch Dobsonian telescope, and he brought it up to Springfield, which is an amateur telescope makers convention, and he took first place for under 16 years old. But yeah, I just don't sit down and do a lot of calculations when I'm observing. But yeah, you have to.
So, the fun thing about astronomy is it is, like Walt said at the beginning, as difficult as you want to make it. There are those of us, like myself, who want it as simple as possible. No math shall be had. There are other people, like, for example, Paul, who likes to run math for fun, or Mark Sproul, who does math because he 3D prints and builds his own telescopes, and we had presentations on that, and like build his own observatory. I know for a fact there are astronomers who worked for NASA and did math for their job. So astronomy is a huge field, and if you don't want to do the math, there are tools and places to help. Like I mentioned earlier, we do have social media presence, or we have a website. If you have questions, feel free to reach out. I pay attention to it. So I won't be able to answer the math questions, but we can usually get one of our volunteers who knows the math to help you out. So was there, let's see, online people, if you have any last minute questions, do get those in. I just wanted to put that out there because stream delay's a thing, and by the time they hear that, we're like a whole minute into the future. So hi from the future, online viewers. Was there any more questions out here? I hear much crickets. Keep in mind, I'm night blind, so unless you're kind of like, or swatting the mosquitoes away because we're currently in their home right now. Bueller. I don't know whether that is a head I'm seeing or a hand. No, it went still, so they're trying to blend into the darkness. Oh, there is a hand?
Yep, there you go. On the right.
I thought I saw motion. I'm like, again, T-Rex from Jurassic Park. Once you stop moving,
How much data does this end up taking? Like, how big of a file size are these images?
The master stacked is about 40 megs, and the individual are about between 3 and 7 megs each. The Celestron's got a 50 gig drive, and then you just take a thumb drive and you put it on there, and you can draw all your files off. The C Star has a 65 gig drive. The cheaper one has a bigger drive, and you just plug into the C Star like it's a portable hard drive on your laptop or desktop, and you can download all that stuff. I actually like the C Stars. The C Star, each file name tells you all the information, the date, which number in the sequence, any filters that were used. It gives you all the information right in the file name, where a Celestron gives you some information, but not nearly as much as a C Star does.
follow-up question, because they had a good question. What file formats is it brand specific format, or is it like a JPEG or RAW file?
It takes a JPEG and sticks it on your phone. So the thing it puts on your phone is JPEG. The stacked master on the hard drive is a TIFF file, so it has much more dynamic range than the JPEG that's been stuck on your telephone. So if you're going to edit anything, you want to go into the telescope. And then the individuals, they're called FIT files, and you need processing software to read those. Excuse me, Cyril or Insight, one of those astronomy programs that's reading right in. A TIFF, you can read a TIFF with any Photoshop or Lightroom, any of those. TIFF is a pretty standard photo. They're huge, but they're pretty standard, and they've got a lot of dynamic range in there to play around with. Much more than that JPEG that's sitting on your phone. That's I think
JPEG has much compressions.
They're like 2 meg JPEGs, I think, that sit on your phone after you're done with a session.
Right, but that was an excellent question.
That was an excellent question. Storage is always, you get into this, there's a lot of storage considerations.
So what I'm hearing is that old cell phone, if you're not trading it in, that should be your astronomy phone, where so you don't take up valuable storage on your actual cell phone.
Thank you.
All right, so it looks like we're done with online questions. Any last minute questions here? All right, so I want to thank you all for joining us here.
Thanks, everyone.
And online. Like I said, do check us out on our website. Go check out our museum area for those of you who are here. And with that, have a good night, everyone. Clear skies than this, and good seeing.